Today, we are going to start a new unit. We're going to talk about exponential functions and logarithmic functions in this unit. Exponentials and logs. Okay, but to start, this first lesson, we are going to review properties of exponents. Okay, we're going to need these throughout the chapter. So hopefully, these are things that ring some bells today. We're going to look at three properties. Okay, the first is the product property. Okay, so I'm multiplying terms that have the same base. Okay, when we're looking at something that has an exponent, okay, in this example, we would say 4 is the base and negative 3 is the exponent. Okay, so all of these terms, all three of these terms have 4 as the base. Whenever we have terms that have the same base and I'm multiplying them together, what do I do with the exponents? Does anybody remember? Add them. Correct. Add the exponents. Okay, so in this first example, okay, if I've got 4 times 4 to the negative first times 4 to the negative third. Okay, well, first of all, what's the exponent on this one?
That's 1.
It's just 1, right? So we need to make sure that we're taking that into account. Right? This is 4 to the first power. So if I'm multiplying all three of these together, I would just add the exponents together. So 1 plus negative 1 plus negative 3, which would get me 4 to the negative third power. Okay, now, another thing that we want to eliminate is negative exponents. Okay, I want to make all exponents positive. How can I do that? Does anybody remember how I can make this exponent positive? I've got 4 to the negative third power.
Make it 4
No, not quite.
Add it to a 1 with a positive third. And then.
No. So, whenever I have a negative exponent, I can take that to, so in this case, this is in the numerator, right? I can put this over 1, right, and say that this is a fraction, 4 to the negative third would be in the numerator. I can take this to the denominator and make it a positive exponent. Okay, so I can say 4 to the negative third power is the same as 1 over 4 to the positive third power.
So you're just reversing it.
Yeah. We can think about it like that. Yeah, so if, and then on the flip side of that, if this was in the denominator, this were 4 to the negative third in the denominator, I could bring it to the numerator as 4 to the positive third. Okay? So whenever we have a negative exponent, okay, we can make that exponent positive by taking it either to the denominator if it was in the numerator, or vice versa. Okay, so try number 2 here. Yeah, there's only 2 terms here.
Will it ever go over 2 terms? Well,
More.
how many terms? Like, what's the max?
Yeah, technically there isn't.
So we could see like 6 terms in one.
You see
You
100,000.
could. I mean, we probably won't see any more than like 3. But yeah, I mean, technically there is no max.
Okay. I was curious. So do you have to put the 0?
Yes. Well, 2 is
I'll do
not
the
the same
cancel.
as 2 to the 0. So if I've got 2 to the first times 2 to the negative first, that would be 2 to the 0 power if I add 1 and negative 1. What? It's not nothing. What's anything to the 0 power?
0.
It's not 0.
1.
It's 1. Anything to the 0 power is equal to 1. So I could have 17 million to the 0 power. that would be equal to 1.
That's me. Yeah.
Alright, so then it's the same idea if I throw some exponents in. Okay? So on this one, I've got n to the negative second times 4n squared, or n to the positive second. I'm going to look at the variables that have the same variables and add the exponents. So here, this n has a negative 2 exponent, this n has a positive 2 exponent. Add those together, that 4 is going to stay. Right? If I've got a number or a coefficient, that's going to stay. And then I would just add the exponents together. So this will be 4 times n to the 0 power. What's n to the 0 power?
1.
1. So this would be the same as 4 times 1, which is just 4. Okay. Try number 4 here. So on this one, remember that coefficient will stay. And then if I add my exponents together, I would get negative 1. Right? So this would be 2 times x to the negative first. And then remember, we don't want negative exponents. So just like we talked about in number 1, if I've got a negative exponent, I can take that to the denominator. Now, notice that all I took to the denominator was the variable. I did not take the coefficient to the denominator. Okay, that 2 stayed in the numerator. The only thing that came down was the term that had the exponent on it. Okay, so I took that to the denominator and said, well, that would be x to the positive first then, in the denominator. Okay, we okay so far? Is that a good thing?
I don't know. Like the crust is like hard, like a hard taco shell.
Alright, so let's throw a few more variables in there now. So on number 5, it's the same idea. Okay, but now we have 2 variables, x's and y. So I've got 4y x to the 4th times 2y. Okay, I just want to multiply the numbers together, multiply the x's together, and multiply the y's together. Okay, I'm just going to go piece by piece. So first, I've got 4 times 2. Give me 8. Then I've got y to the first times y to the first. What's that going to be? Y to the second. And then I've got x to the 4th, and then nothing over here. So that will just stay the same.
What?
All right. You guys try 6. Did we get 4 u to the 5th, v to the 8th? Okay. We feel okay on the product property? If we multiply things with the same base, add the exponents?
That's not bad. Does it get harder than that?
Not really.
Well, I feel like you say that about a lot of stuff, and then I just get lost.
I probably do say that about a lot of stuff.
Yeah, you do. I think because you're smart.
Or because I've seen this many times.
Yeah, smart.
Alright, the second property is the power property. Okay, here we are raising a power to a power. Okay, like in this one, I've got 3 to the third to the fourth power. When I raise something, or raise a power to a power, what do I do with the exponents? Multiply them. Okay, so in this one, if I've got 3 to the third to the fourth power, I'm just going to multiply my exponent. 3 times 4. And I can say this is 3 to the 12th. Okay, the math behind this, if I've got something to the fourth power, this is the same as saying 3 to the third times 3 to the third times 3 to the third times 3 to the third. Right? Fourth power, I just write it out 4 times, and then I get add my exponents together using the product property. Okay, but we can use this shortcut now of the power properties to just say I can multiply those exponents together.
Power property?
Yes, this is the power property.
I want something more. I want to know the
Power of the power property.
what's the number? I thought it was E. What number? I don't know.
Quadrillion.
Yeah, trillion purple power property.
All right, so try number 8. I think so.
1,000.
Wait, what did you say? I said try number 8. You said I don't think so.
And then he's like, 1,000.
Yeah.
Whoa. Now we're all confused. What are you talking about?
Yeah, no number starts with like a 9. I mean,
There is actually a number called 9. There is a number that starts with 9.
Now you're just making it worse.
So here we're just multiplying the exponents together, right? -1 times 2, and we would get -2. Do I have to do anything else with that one?
Yes.
Right, if I've got a negative exponent, I don't want to see any negative exponents, so how can I fix that?
I searched
It's
it.
1 over
Auto
4 squared.
1 over 4 squared. Wait, what autocorrected?
I said, is there a number? And then it said, that starts with P. And now I gave you a P number. Just match P one.
These aren't even P numbers. These are just
P number.
Alright, let's throw in some variables now. Now, the biggest mistake that I see people make on problems like this is they will only raise the variable to the exponent. Okay? I need to raise everything inside of the parentheses to the exponent. Okay? So I need to think about this 3 is 3 to the first. Okay? So I'm going to, it's like distributing. I'm going to distribute this fourth power to both of these things. Okay? So 3 to the first to the fourth power, well, 1 times 4 gets me 3 to the fourth power. And then m squared to the fourth power. Well, 2 times 4 is 8. So this would be the same as 3 to the fourth times m to the 8th. Yeah, we're just like distributing the power. Okay? So this, I'm just warning you now, okay, this is probably where, if you make a mistake, this is where you're going to make a mistake. Okay, you're going to forget to distribute the power. So try to hammer it into your head right now that we need to raise everything inside of parentheses to whatever power we're talking about. Okay, so try number 10.
So like 4 and an X are separate. So I get 4 to the first power. And then you'll be like, I don't know, like, oh,
What? Say what?
Did we get 4 to the 4th, x to the 12th?
Yes.
Alright. So go ahead and try 11 and 12 here. Okay, notice there are going to be some negative exponents. Okay, so make sure that you fix that. Okay, and just get some, or your final answer should be written just instead of positive exponents.
Hey, we are done with the milkshake pretty fast.
Yeah, we are. I think it would go this fast.
Fly through.
Wait, which one?
Oh, 11 and 12.
But they got negative.
They got negative exponents.
Now I'm flipping it for it.
But,
Do I gotta do the whole thing in the fraction? Or is it kind of like one?
So go step by step. So first, distribute your exponents. So this would be x to the negative 16th, and then y to the positive 8th. Right? It's negative 2 times negative 4 would be positive 8. So then the only negative exponent is this one. So this is the only piece I would take down. Say this is the same as y to the 8th over x to the 16th.
I'm flipping it, make it positive. How does that make any sense?
because that's math.
How did I make it?
So if you put it somewhere else, it's positive. Right?
I mean, that's just what they be honest with you.
I mean, actually, it's not great.
I can explain it better to you when we talk about the last property here, the quotient property.
But if I just say, if you flip it in this group.
Yeah.
Alright, I'll take it. Dog. I forgive you. I'm not putting ice in my bottle. Ice is a ripoff. Okay, I'm not even getting to that. Because ice makes me bad. I don't want any of my drink. And I was like, why don't you drink all? Guys, start get that thing done in 5 minutes. If you're letting your drink to sit around,
Tyler hates
I love drink. Why are you gonna water my drink down for me so you can give me less of the drink I want? Huh? No, it ain't happening.
Tyler's friend Big Boy waited 15 minutes at McDonald's just for one seat. Yeah,
Alright, for 11, did we get x to the negative 16th times y to the positive 8th? And then to get rid of this negative exponent, I can take just that x to the 16th to the denominator. Right. Similar idea for 12, we would get y to the negative 8th. So to make that a positive exponent, take that term to the denominator, and we would get 1 over y to the positive 8th. Questions?
Flip it and front.
Flip it, frack it.
Yeah.
Alright, our final property is the quotient property.
free OJ. This is not his shit.
When dividing terms with the same base, what do I do to the exponents? Dividing terms, we subtract the exponents. Right, when dividing terms with the same base, we subtract the exponents. Right, so, for example, on number 13 here, I've got 2 to the first over 2 to the second. If I subtract the exponents, 1 over 2, or 1 minus 2, I would get 2 to the negative first power. Okay. Well, that would be the same as 1 over 2 to the positive first. Right. So, to kind of get at what you were asking earlier, right? This is the same as 2 over 2 times 2. Right? Well, if I cancel out a pair of those 2's, I'm just left with 1/2. Okay, so if we combine this idea of the quotient property, subtracting our exponents with this idea of just canceling things out, we can see how a negative exponent is related to just moving it between the numerator and denominator. Okay. So try number 14 here. We have 3 to the negative 4th over 3 to the 3rd. So subtract those exponents. Yes, sir.
Yeah, science.
Okay.
Say you got your little top thing. I've seen this little thing. You throw a top thing, you spin it high, it's supposed to pull down. How much? You have to go forward, you get liquid, touch the cold, so that it's sitting in the cold. But this game is pretty much full, that it's great up. No. Whenever you let off the water, the little water, do that in the face.
Yes, but I'm not sure.
Well, I don't know if it's like small.
Could be.
Yeah. You get kickback pain.
It's possible.
I did that. Thank you.
So, negative 4 minus 3 should get me negative 7. Right? So this would be 3 to the negative 7th, which would just be the same as 1 over 3 to the positive 7th. Okay? So we can throw variables in there as well. So on number 15, I've got a to the 4th over a to the 1st. So if I subtract my exponents, what do I get? A to the 3rd. So on number 16, then, we throw in some coefficients. So I've got 4 over 3. What should can I do anything with 4 over 3? No, right? I can't reduce that fraction. That part's just going to stay. Then I've got r to the negative 4th over r squared. What should I do with that? Yeah, just subtract the exponent. So negative 4 minus 2 would get me, what would that get me? Negative 4 minus 2, negative 6. So this would be r to the negative 6th. Right now, that would be in the numerator, right? But I want positive exponents. So what I would do is take that to the denominator and make that r to the positive 6th. You okay with that one? All right, then the last two. Okay, we throw in a couple more variables. Bless you. So go ahead and try the last two here. And we will be done very early today.
Yeah. What you gonna do? Yeah. You gonna do it one? I'll smack his mouth. Yeah. I thought you got fun with it.
Thanks.
I'll put you up at chicken. One more gonna put smack his mouth. Hey.
See, look like crack
Point.
crawled out of their teeth.
Good. Alright, I gotta flip it. There. Done. There. I just put negative 6 in the board.
Wait, you don't.
Oh, yeah.
Really have
Zero
to-
power.
Anything to the 0 power. So it would just be 3 times 1, which is 3.
Alright. Now, ladies. Yeah.
What's good with me too?
Oh, I know what
Alright, for 17, I think, so we first, 3 over 3 is just 1, right? Then x to the negative 4th over x squared would be x to the negative 6th, negative 4 minus 2. And then here, 3 minus negative 3. It would be the same as 3 plus 3. So that would be y to the positive 6th. Then, I want to get rid of my negative exponent, so I take this x to the 6th to the denominator. So my final answer should be y to the 6th over x to the 6th. Then, number 18, I get 3 over 1, so that's just going to be 3. Then u to the 4th over u to the 4th. If I subtract my exponents, I would get u to the 0. And then there's nothing to combine v to the 4th with. But then u to the 0 power is just 1. So I would have 3 times 1 times v to the 4th, which is just 3v to the 4th. Questions?
No, that's just